obviously chapters 11 and 12 here, I only picked a couple of topics, so it's not going to be all that long. But there's one that I can't give you a good homework problem on. I can't. So the best thing I can do is just spend about 5 minutes here and talk about it and point it out. I believe I had you Learn Smart go over it, although I'm not 100% sure. It's in chapter 12. It's called a balanced scorecard. Okay. And what basically happens or has happened is that they accused us accounting, finance folks, whatever, of spending all of our time focused on, focused on these financial indicators. Okay. And they go, you know what? There's so much more to be a success. Okay. Than just did you meet the numbers? And so a balanced scorecard is a way to do that, which kind of has you take a look at the entire organization. And what it says is what we're going to do is create 4 measures. Numbers are important, but they're not the only one. Okay. And we're going to do one for customers and maybe look at things like customer satisfaction numbers. Okay. And find out how well those numbers are going. Internal business process. Are we, improving the way we do business, our processes, whatever. And then learning and growth, when we provide an opportunity for our employees to grow as individuals, what have you. And so what they start to do is they start to ask, questions, if you will, okay, and learning and growth measures, okay, percent of that accepted our job offer, okay, perhaps in recruiting, skills, okay, maybe the number of employees I sent for training, okay, or the number of employees that I was able to give a promotion to. Okay, percentage of positions filled with internal candidates. So all these are ways of looking at your company without just looking at your profit and loss. Okay, those are examples of learning and growth. Internal business process. Did we develop new products? Keep in mind, I could make my numbers look really good by laying off a bunch of my engineers so I come up with no new products. But keep in mind, pardon my language, that screws me down the road because I don't have new products. Okay, so I can make my profits look really good, but not be helping the business grow or whatever. Okay, so here are example of internal process measures. Okay, number of patents that we got approved. How many warranty claims did we have? Okay, did we have a lot of warranty claims? Maybe defect free. Okay. Average batch size, a whole bunch of different ways. It all depends upon the business you're in. Those are internal business process. And finally, customer measures. Okay, how many customer referrals did you get? Okay, maybe market share, how many customers left, defective. Okay, average revenue per order, average revenue per customer. The bottom line is what doing a balanced scorecard does is it forces you to look at not just the numbers, not just the financial numbers, but looking at the customer, your internal business process, learning and growth, and make sure you're doing things that, the financial numbers tell us we're a success today. These ideas of looking at customers, internal business process, learning and growth will make sure that not only are we successful today, but we're successful down the road. Questions. It's really hard to come up with, homework problem or anything on that, but it's important that you understand what's going into that balanced scorecard. I'm getting this thing and I don't know why. There we go. So if that being said, let's go ahead and take a look. And I only have two problems to do today, so it'll probably be relatively quick. And That's it. One from chapter 11, one from chapter 12. And the chapter 11 one will be exercise 11.1. Calculate the return on equity, and it's on page 522. And it asks for 3 numbers. Sometimes this is associated even with GE. I don't know if in the textbook they did, but GE was kind of the first one back in the day that started to use these types of things. And what they ultimately did is that they had a complete formula, and they knocked it down. And the reason is, okay, return on investment, and a little bit of lecture here, but kind of, return on investment is actually calculated, okay, as net income divided by operating assets. And usually we use an average for that. And by doing an average, the reason why we use an average is, you know, a company during a year will buy a lot of equipment, sell a lot of equipment. And so the question is okay, how many assets did I have? And so what they do is they use an average. They take what it was at the beginning of the year, what it was at the end of the year, what the assets were at the beginning of the year, what they were at the end of the year, divide by 2, come up with an average. So that's how you find your return on investment, or your what have you, or return on assets, okay? So now the question is, how do we calculate it? And what they do is they break this up into 2 pieces, okay? And the first one is margin, okay? So the first question asks us, hey, what is the margin? And to calculate the margin, we take net income and divide it by sales. And so in this case, it would be 600 grand divided by 7,000,005, or 8%. So that's my margin. The other question, or what have you, asks you to go ahead and calculate the turnover. And the turnover, and there's a lot of different turnover ratios you can use, but the turnover ratio tells us how many times are we and you can look at inventory turnover. There's inventory turnover ratios and what have you. There's lots of different turnover ratios, but the turnover we're looking at here is sales divided by average operating assets. Okay, and our sales here were 7,000,005. And our average operating assets, they told us here, were 5 million. So that equals 1.5%. And now the reason why we do this. I had here up at the top that return on our average return on investment. I would prefer that they called it a return on assets, but I'm going to go with the terms they're using. I don't want to confuse anybody. Is simply taking net operating income. And in this case, net operating income was 600,000. And divide it by, say, average operating assets, which were 5 million.
And if I take 600 grand and divide it by 5 million, see if I can get my calculator on my phone to work. 600 grand divided by 5 million. It's 0.12 or 12%. That's the quick down and dirty way to get there. The problem was that we realized is that misses what's going on. And so what we do is we break it up into margin times turnover. Okay, so we're going to have 8% times 1.5. Okay, and that 1.5 is not a percent. Okay, it's a turnover ratio, so it's not a percent. So that's 12%. And you go, well, Mr. Sass, that's exactly what I calculated up here. And now you go, yep, you're exactly right. Okay, and so then the question becomes, okay, why did we do it the way, why did we do it this margin times turnover? It shows us all the pieces involved. What happens if you just use the return on investment and take net operating income divided by average operating assets? You lose track that sales matter. So by doing margin times turnover, we've got margin, which is net operating income divided by sales. And the turnover ratio, sales times average assets. Okay, and that equals return on investment. What often happened back in the day is that you'd forget that sales are an important part. I mean, those cross off, which is why we get net operating income divided by average assets. But things get lost. If you just go with this equation here, things get lost. Okay, whereas if we break it up into its component parts, okay, if we break it up into its component parts, we don't lose fact that, hey, sales matter here. Sales matter. Questions on that? Don't know if I can pull this up quick. Last item for today, and the last item for the semester, and the last item for what have you, is going to come from chapter 12. And I saw this today. And there is a chip shortage. They've closed down, auto factories are closed down all over the country due to COVID, due to changing demand, due to canceled orders, whole bunch of different reasons. There is a shortage of chips, and chips go into pretty much everything. And as I was reading this article today, okay, notice the bad news is there's no quick fixes. So if you think it's going to happen in short order, it's not. But what I saw them saying is, chip makers can only add incremental boosts to capacity from existing plant, executives say. Okay, building a new fabrication plant can take years because of the scale and complexity of the equipment and space needed. Okay, so what they're doing, I don't know where it was. Racing to fill orders, Global Foundries, based in Santa Clara, is dispatching engineers to find ways to squeeze out even the smallest amount of extra production from its facilities. Okay, delaying certain maintenance tasks, which I'd never, encourage, and speeding up by a fraction the rate at which wafers move along the line. And I saw this today and I go, that fits right into what I want to talk about from chapter 12. And that brings me to chapter 12 and the exercise I want to talk about there, which is 12.3. And let me find my. We're doing exercise 12.3, and it is on page 556. And the thing to realize here is that there are a lot of times involved, okay? There are things like wait time, okay? When you've been on a factory floor or production facilities, whatever, there are times where the parts get there and they wait, okay? As a customer, you know what I want to pay for their wait time on their assembly line? 0. That's not my problem. The fact that you have to store it and insure it and whatever ain't my problem. I don't want to pay for wait time. Okay. Now, process time, the time it takes to actually make my car or whatever it is, I'm willing to pay money for that. Okay. I'm willing to pay money for that. When I buy a car, that's what I'm buying. I'm buying the time it costs to make the car. Okay. Inspection time. As a customer, I want to pay 0 for that. Make the dang thing right the first time. Okay. And you shouldn't have to inspect it or whatever. I don't want to pay for that. I'm paying for the car. Okay. Move time. Time it takes to move up and down the assembly line. Once again, I'm paying for the car. How much it costs you to move it around and how many times you got to move it or whatever, that's your problem. Okay. And finally, queue time. Wait time is after the order and before you start. Okay. In queue time, I'm going to check my spelling here, is the time it's spent on the assembly line waiting. And once again, 0. Okay. As a customer, I don't want to pay for that. So the whole question boils down to, and it was alluded to in that article, is there any way I can shorten time? Okay, because customers don't want to pay for this. They don't want to pay for move time. They don't want to pay for queue time. They don't want to pay for, all they want to pay for is the time it takes to make the product. Okay. And throughput time is the sum of all 4 of those. Okay. Throughput time is the sum of all of those. So with that being said, let's go ahead and answer the questions to 12.3. Part 1, question 1, asks us, compute the throughput time. Well, the process time we're going to take the process time. Okay, and the process time was 2.7 days. Okay. And usually these things will be in either terms of days or minutes or something like that. Inspection time. And inspection time, according to the table there, was 0.3 of a day. Move time, move it around the factory floor, what have you, was 1 day. And queue time was 9 days. Pardon me, was 5 days. So when I add all that up, 6, 7, 8, my throughput time is 9 days. So it takes 9 days from the day I start manufacturing to the day I'm done. Okay. So that's part one. Now, part two, which is kind of, I think, what the article was getting at, what have you, okay, is compute the manufacturing cycle efficiency. Well, the manufacturing cycle efficiency is going to equal the value added time divided by the throughput time. Okay, so what I have here is 2.7 divided by 9.0 or 0.3. Now, what that basically is telling me, my customers are willing to pay for the time it costs to process something. They're not willing, they don't pay for it. When you think of buying a car and you spend that 30 grand, 40 grand, whatever that number is, you don't think, oh, you think you're spending that 30, you want to pay that 30, 40, 50 grand for the actual metal tires, the car. How long it takes them to move it around on the assembly line, you don't care about. That's not your problem. The amount of time it has to wait before it goes into the next, process, or it comes out of the paint booth and it has to wait before, as it dries, for it to go. You don't care about that. You're buying the car. You want to pay for them actually doing work, not it sitting around. So what this is saying is only 3/10 of the time, 30% of the time, is it something customers are willing to pay for? So then the question from a business perspective, okay, means that, and this is getting to question 3. Question 3 says, what percentage is not spent non-value added? Well, if 30% is value added, 70% of the time, and I'm going to do it as a percentage, and keep in mind it's 0.70, okay? 70% of the time is stuff customers don't want to pay for. And so the question then that comes up is, and the thing that that article was alluding to with the engineers is there any way I can reduce that time? Is there any way I can produce more and make it, and keep in mind, you may end up cutting it, cutting that some of that wasted time and not be able to get any more products because you're working full out. Products can't make more. But if there's any time to be saved, and also any money to be saved, you start looking at that 70%. Is there something I can do with that 70% of the time? Okay. To make my plants, what have you, more efficient, okay? Which brings me then to question 4. And question 4 asks for what is the delivery cycle time? Well, the delivery cycle time is going to be the wait time, which is the time from the order until the plant gets going, okay, plus the throughput time. So we already calculated throughput time was 9.0. The wait time was 14 days. So we've got 14 plus 9 or 23 days. Now, as I'm doing this project today, as I'm doing the homework today, I'm sitting here on a Dell computer. I've got a Dell laptop, a Dell desktop of some kind, and I'm writing on it. Dell was one of the first ones to do this. And when they just started doing it, Dell was an industry leader in cutting out these items, okay? And in fact, as a general rule, when you went on the Dell website back in the day, I can't tell you how it is today. Your computer would be shipped in something like 2 days, okay? So these two times, if you will, was 2 days. And you go, how could they make a computer to order in 2 days? When you submitted an order to Dell back in the day, it immediately issued something like 50 emails, 50 purchase orders, okay? And those purchase orders went out to all their suppliers, which were all right in the same area, okay? They were located nearby, and it said, tomorrow, I want you to deliver 1 hard drive of this size, 1 CPU of this size, 1 whatever else goes into them, okay? And it was an incredible amount of emails that went out immediately. And I want it all here tomorrow. And so what would then happen is I'd place the order today. When I placed that order, it would ship out a bunch of purchase orders, emails, what have you, that said, I want this stuff here tomorrow. And then when all this stuff showed up tomorrow, they put it right on the assembly line, made it, and they had their computer out in 2 or 3 days. For the time, and this was probably back in the 90s when they were doing this, maybe early 2000s, that was unheard of. That was unheard of. You know, you'd go into Best Buy at the time, what have you, and you'd be buying computer technology that was basically out of date because it had been sitting on Best Buy's shelf and shipped and what have you. By the time you got it, it was 3 months, 6 months, 9 months out of date. And here Dell was producing computers in like 2 days and shipping them. But the reason they were able to do that is they were able to get rid of the wait time and to reduce that throughput time to where it was virtually just process time, what you were willing to pay for. And that's what in the day made Dell so popular and kind of gave them their name. And then finally, question 5. If by using lean production, which is what Dell was using, okay, and what lean production aims to do is to get rid of some of that outside time that's not used, okay? Provide customers with what they're willing to pay for, okay? All queue time during production is eliminated. What will be the new MCE? So we're not going to have any queue time. So this queue time is gone. Whoops. This queue time is gone. So instead of 9 days, it's only going to be 4 days. So we're still going to have the 2.7. Okay, our new MCE is still going to have the 2 points. I'm going to put it up here just so we've got it. It's still going to have the value added time of 2.7. But now the throughput time instead of being 9 is only going to be 4. So we've improved it to, 67.5%, 0.675. Okay, this gives you an idea of how important it is and how, I don't want to say simple, because I mean, if it was simple, everybody would be doing it, but I'm going to use the word simple. If you can just get rid of some of that wasted time on the production line, what have you, okay, in this case, just getting rid of the time that the items spend waiting in line, queue time, solves so many issues. Questions? Anybody? I think today's is, after last week, today seems like a breeze, at least hopefully. Right, Tracy?
I'm still here. Yes, you're right. This is a breeze.
I know, I'm just giving you a hard time.
I was writing.
That's fine. That concludes the semester. So, and I'm saying conclude, not really, because we're gonna have a brief class next week. Okay, and the purpose for next week, let's just kind of lay it out here. And I don't know if I've got it as one assignment or two. I should probably look. No, I'm gonna just chapter 11 and 12 assignment. I think I've got it as one, but I'll have to check. Okay, I think it's one, but it could be two. Okay, and I think there's a quiz as well, but it's a short one. And that one also is really easy. I don't even have videos on how to do those problems because they're really quite simple. So for next week, we're going to do chapter 11 and 12 assignment and the quiz, which will be a short one. I'm going to then use a little bit of class, is I'm going to call it a review and an ability to ask questions if you have any. Okay. And then that'll be the semester, and I will open up the final. So I'll open up the final next Tuesday. And it should be done, I'm going to say, by the 4th. And that'll be a little bit ahead of schedule, but that's fine. I pushed you early on because of how it worked with spring break, what have you. So we're in good shape as far as all of that goes. So I'll open the final next week. We'll talk about the final. One quick note, the final does consist of one problem, and it is flexing a budget. So it's not a terrible one. Okay, but it is a budget flex. So that'll be the problem. And then once again, the other questions will be multiple choice, very similar to the quiz questions, what have you, which is why I have them, which is also why it's important that if you have any questions, you take a look at those videos if you have any questions. And I think those videos will explain exactly how I did it. So you won't even have any issues there. But we'll use it as a quick review, let you ask any questions, and then I'll open the final.
Is the final going to be timed?
It will be. Were the other two exams timed?
I truthfully don't remember.
And Emily, and that's the reason why I mentioned it. They were. You'll have like 2.5 hours. Okay, but I'm giving you plenty of time. Okay. So it's not like it's going to be an issue. You will have to do it in one sitting, what have you, but it's not like the 2.5 hours to do it gives you plenty of time. If you've organized your notes, and you've kind of looked at, okay, how to do various problems, you'll be fine. Okay. But it is timed, but it's typically 2.5 hours, which gives you more than enough time. So time's not an issue, which is why I asked.
Okay, I just figured it was timed because I don't remember last time, so I'm sure I had enough time.
Yep.
And how many chapters is the